Okay, so we are going to continue what we've talked about last time. We're going to go through a few things. I think by end of today, we're going to be done with week 2. And hopefully the next day you're coming in, we'll be able to get into week 3 and almost catch up, okay? As I mentioned, always this class starts around 10 minutes late, as the other class ends 10 minutes early to set things up from one class to another, and we don't have a break. We go right to the end of the class, which is going to be on at 11:40, I believe, right? 11:40 we end, right? I think so. Anyway. Okay, so first thing I'm going to do, I'm going to bring up what we've talked about last time, kind of go through it quickly. 15, I'm going to fix that. I'll do that later. So that's September 15th. I'll fix that later. Let's go over here. Hello. So we talked about pointers. We went through pointers, understood what pointers are. We talked about integers, and we said how integers can be signed or unsigned, and when you make an integer unsigned, essentially the value doubles and there are no negative values. We said that literal values, if you want to put, if you want to specifically have a literal value that is long integer or long, you add an L or LL at the end. If you want it to be unsigned, it's going to be ULL. We talked about floating point numbers, and we said floating point numbers are kept in the computer in a completely different way. It's kept as a scientific notation. Therefore, what it keeps is one integer number and the exponent of that number being multiplied 10 to the power of. And because of that fact, the precision of a floating point number is the significant digits, number of significant digits that it has, and that's for floats, it's 7, which means leading zeros and trailing zeros removed, 7 integers back to back. For doubles, that was 15, and for long doubles, it goes so. We talked about booleans, and say booleans are kind of a compensation for people who are not comfortable with truth and falsehood in C. In C language, we said false values are essentially 0, and true values anything that is not false. So therefore, any value is acceptable as true. They added this type, and this type automatically casts everything to 0 and 1, which means if you have 0, it's going to be 0. Anything other than 0 will be converted to 1. Still, C++, like its mother C, considers everything to be true if they're not 0. So condition checking is the exact same thing, no difference. But whenever the language produces truth or falsehood, it's either 0 or 1. So the result of a logical operator is only 0 and 1. But when a condition is tested, it's 0 or not 0. We talked about characters, and we said characters are nothing but integers that are only 1 byte, minus 127 to positive 128, to minus 128, positive 127, or 0 to 255. Void, we said there is no such thing as a void variable because it doesn't make sense. Void means no value. Therefore, return type of the functions can be void, but we don't have any void entity. You cannot call void I. It doesn't make sense. It means I is nothing, so don't put anything while you're creating nothing, right? We talked about initialization, and we said initialization is now done with the curly bracket in front of the variable, and we specifically put stress on this initialization, meaning, which is essentially setting a value at the moment of creation. That is initialization, and that only. You cannot use the empty curly brackets or curly brackets to set something halfway through your program. That's setting. It has to be initialization. recalling the code for it. I'm just going to bring it back quickly. So what I said is that it's number 13 is what we do from now on. You don't need any assignment, anything. You just do it that way. And if you leave that empty, what happens is this. It becomes defaulted. If it's an integer, the default value for an integer is 0. If it's a pointer, the default value for a pointer is null pointer. If it's an object, the default value of the object is its default construction, whatever it is. And that was initialization. Then we talked about auto. We said auto is essentially automatically setting a type of a variable based on what is being initialized to. So if I have some variable initialized to 2.5 and I put auto in front of it, essentially auto a is equal to 2.5. 2.5 by default is a double, therefore your a become a double. Auto is used many, many times in future when we are dealing with templates. It's going to be extremely useful. I'm just quickly going through pointers. We talked about it. I don't want to go through it again. What was that PRG thingy at the end? Characters. So we're good. Now, questions on what we had last time? Suggestions? Objections? We're good? All right. So now I'm going to see where actually my executable is stored in this program. Let me just first fix this thing at 15. It's kind of bothering me. 15, I'm going to set it like that, so that's September 15th. All right. Now I'm going to right click over here and I'm going to say open File Explorer. So we're going to have the location. I'm going to copy the path. Then I'm going to open a command line, and 3 years later in the command line I'm going to go CD, and that's where everything is. Prompt is too big, so I'm going to say prompt $G, $G. That's going to give me only this. So I have these values. In x64 is where my executable is created in the default because I have an x64 system. CD x64. You can do it. There we go. All right, and CD debug. All right, so that 04 September Sep15 because that was the name of the thing. Sorry about that. Let me recreate it, see if it actually recreates it. Let me give me a second. Let me try a rebuild. I want to see if it actually changes in the settings or not. That's not the one. Nope. Leaves it. Oh yeah, it did. So this is what I'm going to do. Remove everything. That's fine. Is a directory? That's fine. I'm going to rebuild again. Now go back to the command prompt. Do an ls. That's why 04 yada yada exe. So that's the command. So if I actually say 04 September 15th and run it, my program runs. Are we okay with this? Are we okay? Now, when you do command line statements and commands, what do you do? Like you're saying, for example, if I want to copy the stuff that I have over here, I can say CD. I can say copy, for example, 04 September 15th .exe to my prg.exe. So this copies one thing to another, right? So I essentially exe. Okay? You okay with this? Now when you do CP, this is a program written by someone, right? Where the input is coming from? How does it know what is the file name? Why everybody's quiet? Your cell phone good? When I say CP, where does it get the file name? Does it ask you what is the file name? It comes through the command line, right? How the heck we get that?
Check for white space.
No, actually this is what it is. I'll show it to you. It's about the real syntax of main. So main is not, this is not the signature of main. Main actually receives 2 or 3 arguments. 2 we mentioned in our notes. I'm going to tell you what the 3 is because it's very important. Okay? So it receives 2 arguments. The very first arguments, int, you can call it a, don't. All the community, for as long as I know, calls that argc for argument count. And the other one is an array of strings. So how do you use a string? Like if you want to print a string, C string, in C language, what does point to a C string? It's a character pointer, right? Right? So if I have a character pointer, I have a string. Now I have several strings in the command line. I have a CP, I have a first name, I have a last name, right? So these are series of strings. So to have series of strings, I need character pointer array, correct? So that's exactly what I'm going to put over there. So the second one is going to be a character pointer argv array. So essentially, argv0 is the first thing on a command line. argv1 is the second thing on a command line. And it keeps going like that. So now I can actually write over here a loop. I can go for integer I set to 0, I less than argc and I plus plus. Okay? And I can type argvi. I can actually print this out. So I'm going to say C out to kind of make it look better. I'm going to say I plus 1 to show the number of the argument. And I'm going to show a column. And I'm going to then show the argument. And I'm going to go to new line. Now, when I press Control F5 and I run this program, what happens? The program runs, and it presumably is calling the executable that it creates in debug, right? So if I actually Control F5 this, I only have one thing in a command line argument, that is the name of the executable. Take a look. You see? So it actually puts the qualified name. It doesn't do the path. It literally puts the qualified, the absolute path of what it's supposed to execute. Okay? Obviously, if I go back to the command line, if I go back to the command prompt, okay, let's clear this. Okay, if I go to the command prompt over here, if I say 04 September 15th .exe and I hit enter, that's the only thing I have in there. What is on the command line is going to come over here. You see that? You okay with this? Now, if I say over here, 1, 2, tie your shoe. 3, 4, shut the door. 5, 6, pick up. Okay, forget it. All right? So if I write something like this, what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 things on the screen, on the command line, right? And when I hit enter, this is what I see. So the first one is whatever. It doesn't care what is the name of your executable. That's not what it receives. It shows what you put in here. Anything you put in there, anything that causes the execution, that's what it is. That's what it does. You okay with it?
Get to that window?
Pardon me?
How do you get to that window that lets you do the prompt thing?
You mean command prompt?
Yeah, because
What do you have? What is your machine? Is it a, okay. just put click on Start button, type CMD and hit Enter. CMD, Enter. That's command prompt.
Yeah, but how do I execute the program like that?
Okay, so what you need to do, first of all, yeah, okay, I'll explain. So first you have to see where this executable is created, okay? The executable is created where your project is. If I right-click on the project and I'll go Open Folder in File Explorer, are you looking at the screen?
I have it open.
Okay, Files Explorer, and then we come over here, and I'm going to explain something else later after I explain this to you. When I do this, take a look, you see that? Okay, I copy that, okay? Now I know where the path is. I can open the command prompt, and in that command prompt, if it's in the same drive, I have to go CD, and I type it over there. Now it goes to that directory. In that directory, you have, depending on what you have, if it's an x64, you have to go to directory x64. Then in x64, you have a directory called debug. And in there, you have all the executables, right? Got it? Yeah. This is not a lab. This is a lecture. Don't follow me on your computers. Don't try to do what I'm doing in class. That is only distraction. It will not teach you anything. You can later on look at the screen and see what I did and repeat it in the lab. Please don't do that, okay? I'm sorry, it's not that I don't like that you're actually listening to me and trying to do things, but that's for lab, not for here. I'm supposed to keep going and teaching you stuff. Anyways, so that's that. So these are the things that you get. And now go home and write a copy command. How do you write a copy command? When you just, first of all, it's the name of your executable. You don't care about that. So you go to second argument. The second argument is the name of the source file. The third argument is the name of the destination file. So you can actually check if that number is not 3, then you show a help. It means they didn't put the right amount of arguments on a command line. If it is 3, then you pick the first one. It's a file name. You try to open it. If it opens successfully, good. Then you open the other one. You copy byte by byte. If not, you give. So you can literally write a copy command if you want to. Anything you want, you can do. Okay? You can lift up the operating system is written that way using C. So Linux is written in C. By the way, this is not C++. This is C. Yes.
So the first argument in ARGB is the name of the exe?
Yes.
Why is it like that?
Why do I have 2 ears, not one? They designed it that way. And I think it actually makes absolute sense. You need to know what is the name of the executable. So I can actually write a program to make sure you don't rename my executable. When the program runs, I'll check the name. If the name is changed, I'm going to say, this is not right. The name of the executable is supposed to be this and that. Okay? All right. Are we good down to this point? No? Okay. What's wrong?
I didn't get it at all.
You didn't get it at all?
No, I cannot understand what's the meaning that we're doing this and what's going on.
Okay. First of all, put your advanced hat on. We are teaching you advanced stuff. Let's say you want to write the Linux operating system. If you want to pass and program values on the command line, how you want to do that? That's how. So essentially, this is what I'm saying. So this is the program that I have written, okay? And I appreciate these questions actually, thank you, okay? So, clear. So, you know what? I'm gonna write you the copy command right now, as we mentioned, okay? So what I will do over here, I want to write a copy command. So let's save this. So this is a command line args. So let's say I want to write a copy command. So what do I need when I want to write a copy command? The copy command is done like this. Copy or whatever, copy, right? Then you have the source file. And you have the destination file, correct? That it's done. That is how it's done, right? Using argc, you know that you have to have 1, 2, 3 things on the command line. Okay? Number 2, you know that second argument is the source file. Third argument is the destination file. So the very first thing that I'll do over here is this. I'm going to say if argc is not equal to 3, it means they don't have the right syntax. They are not issuing the right command. I have less than or more than stuff over there, right? Therefore, I'm going to say over here, cout, I don't know, help. And in here, I'm going to say copy source file, and then destination file, or that's file, and then enter. Okay? And I end L. So that becomes my first thing. Else, now I'm going to write the copy. So I'm actually writing a code that does copy for me. Okay? Now if I'm here, it means they actually put 3 things. Therefore, arg1, this is arg0, right? Arg1 is the source file, and the other one is the destination file, right? So I'm going to say iStream. I need fstream over here. Fstream. Now in here I can say ifstream, sorry, in file, and in here I'm going to put argv0. Oh, sorry, 1. So I'm literally opening the file for reading, right? Now if not in file, it means the file doesn't exist, right? Now you show the message. You're going to go cout over here. You're going to say argv0 or cannot open argv0. Sometimes it's too much help. All the things that you do, it shows too many things on a screen. I hate that. Okay? Like that. So if that's the case, now what I need to do, so if I'm here, it means it's actually opened, right? The source file is open. Now I have to open the other one for writing. So I'm going to say OOP345NBB out file. What is the other one? What is the other one? What is the other one? The other one is out file arg v1. Sorry, 0, 1. This is 1. This is 2. Then I'm going to write over here, if not out file. So you see, I'm just writing the code as I go. So in here, I'm going to have cout, I don't know, error for out. We'll fix that later, for out. Okay? Now, when I'm at this else, it means everything's good. I have the source file open. I have the destination file open. I read from the file right into the other one. So all I need to do is to say character ch. Then I'm going to say while in file dot get in ch. Actually, get, I think, receives an integer, right? Or no, ch, right? Ch. Now I'm going to say out file dot put ch. Done. Copying is done. Finished. Read from. So now I have written the command line. So if I compile this thing now, rebuild this, rebuild. And if I go to my command line, if I can find it, command prompt, now the September 17th thingy, so I can go 04 September 15th.exe. Okay, first of all, I'm going to copy that into, say, what do I call it? Copy, okay? Or my copy. my copy.exe. So now if I say my copy, it's going to tell me help, copy source file, destination file. And now I can actually copy stuff with this. So that's what, so I can actually say now my copy. So in here, I don't know, do I have nano text.txt? Yes, so 1, 2, 3, Control X, get out. So now I have that text.txt. I can say my copy text.txt to cp.txt. Oh, it's actually giving, isn't it 3? Oh, what did I do? So I have a bug. Let's fix it. What did I say? argc is not equal to 3. Actually, that's a beautiful thing. Now we're going to test something. So it says if it's not equal to 3 to do that. It is 3. Did I put 4 arguments over there?
Yeah, you put 2.
Oh, sorry. Okay, there we go. So now if I actually do an ls, you see that I have a cp. So if I say cat cp.txt, you'll see 1, 2, 3 is over there. So we wrote a copy command, as easy as that. So that's what is it for. Does that make sense? Okay. Again, we are showing you technical stuff now. This is 3, 4, 5. So probably your assignment 1 that is up is actually using that. Now, if I want to actually test this, how do I do it? If I want to debug this, how do I do it? To debug it, and please listen to this carefully. To debug using your IDE, whatever you have, this is what it's going to be. Remember what I told you about electronic devices? I said if I get you laughing at your screen, everybody loses their screen. This is your last warning. Okay? All right. So, and also, no mobile devices. Under no circumstance you need to look at your cell phone. Put it in your pocket now. Your laptops I can handle. Cell phones, it pisses me off. It's disrespectful. I'm putting my heart over here, and then you're okay? All right, anyways. Essentially, grow up, okay? We are in college now. It's not high school. All right. So, yeah, what I was saying, to actually debug what we need to do, we need to go to the properties of our project, open properties. If you look at debugging, there is a place that says command line arguments. So in here, I can actually say a file.txt and something else, .else. So if I do something like this, the executable is the first, this becomes the second argument, this becomes the third argument. So if I click on OK and do Control F5, obviously it cannot find that file, and it says cannot open file.txt. So you can actually put all the command line arguments that you have right in here, okay, and test it. So now if I actually write over here text.txt and the copy.txt, now I can actually walk through it. I can press F10, come in here, and I see argc is 3, so it is good. It comes to the next one. argv1, I can actually highlight it, and I see that's text.txt. I can see if it can get open. Yes, it cannot open it. Huh. I don't know why. We'll find that one later. So yeah, it couldn't find it. The path is not set or whatever. It's not important. Anyways, you can debug it. Okay? But that is another story. We're going to go through it later. Questions? Okay. Also, the working directory is important. So you can actually, in the property over here, you can actually tell what's going to be. Like when you're doing debugging, the debugging type is here, command line arguments are there, working directory. You can specifically mention where is the current working directory and select it. So The reason it couldn't find the file because the path for the file was the project, not the debug place. If I put the file in the path, it works. This is the project directory. That's the working directory. I put the file in the debug directory. That's why I couldn't find it. Okay, so if you have any place, specific place that you want to put stuff, you can actually set where your working directory is, and that becomes the current directory in which it's being executed from. So the reason that I couldn't find it was that, which means I can literally go over here and I can open, I can go to x64 and go over here and get text.txt, copy that. And go back to the project directory, paste it over here. Now if I run it, it's not going to give me an error. It actually finds it, okay? These are the things that you need to know, okay? I'm not going to go through it anymore. We have already done this enough, so I'm going to write over here B command, a copy command. Next thing that we do not have in our the next thing that we do not have in our notes is the third argument that this thing accepts. So if I come back over here, there's a third argument over here that is again an array of character pointers. The difference is that the size of this is determined exactly like the size of a C string is determined in C program. In C, to have because we don't know what the length of the string is, we null terminate it, right? So we go until we hit the null. That's how C strings work. They do the same thing over here. So this envs that you see are pointers to all the environment variables in your operating system. Everything. Username, number of CPUs, home directory, path, anything that you have in your operating system is in there. But because we don't know how many, you print them, you go through them one by one until that pointer becomes null. So in here, I'm going to say cout command arguments. And L, and I can actually say over here argc command arguments. I can say actually 10 command arguments, 2 command arguments, whatever. Okay, so I can, but for the other one, I can't do it. So in here, I'm going to say cout. I'm going to go to new line first, then I'm going to say environment variables. Go to new line. And I'll use the exact same strategy. So I'm going to actually create a loop. But instead of checking the argv, I'm going to say, is envi null or not? So if envi has something, I'll show it. If env has something, I'll show it. If it's null, I'm at the end. There is nothing more. Now, if I run this program, you will see all the things that Windows sets. Take a look. All users, program data, common files, home path. So if I want to know what is the home path of the user, the home drive is C. What is the local app data? Where all the local app data is? What is the operating system? Like if you know the history of Windows, Windows NT is something that came out of the very first reliable Windows that got created after Windows 3.1 25 years ago. All the Windows that are getting created are based on that architecture. That's why the operating system is called Windows NT. Okay? Path. All the path that is set in my system. I don't know. What is my processor architecture? What is the type of the processor I have in here? processor level, I don't know, program data, username. So what is the domain name? You see SENA-DS, something like that. Every single thing that you want to know about the operating system is in here. And remember, if you run this on Linux, it's a different ballgame because it's a different operating system. You're going to have different values coming in. One thing to catch, 51, you see, it's one string from here to here. It's not separated into. It's your responsibility. If you want to, for example, find out what is the temp directory, you have to search through the whole string, see which one starts with temp. If that's the case, does it end with an equal sign? If that does, you split it in two. What is at left is the name of the variable. What is at right is the value of the variable. Okay? That could be a nice question for a quiz, to write a program that searches through. Actually, you know what? Yeah, that's a good one. Give me a second. So, a good programming quiz question would be, we are NBB, right? Huh, the last one is yours in here, actually. I'm going to say week 3. Week 3. Okay? So, the question would be, write a command that prints the value of an environment variable or prints an error message if it doesn't exist. So what you do, you write a command, say whatever you want to call the command, say env. So you write env path. You hit enter, it shows what is the path value. And if it's not, it says no such environment variable. So you say env vslang. Then it's going to tell you 1033. Or if it doesn't exist, it's going to say it doesn't exist. Write that command. It's a perfect practice and might be a question in your midterm. Something like that. It's a very nice question for midterm. Any other, down to here? We're good? The funny thing is that we haven't even started the lecture yet. All right, so question now is yes.
Is there any other parameters for main other than env and AOG?
No, that's it. The 3 is what it is.
I didn't know about the third one.
Yeah, I know. Most people don't. That's why I mentioned it. Okay, this is something that when you actually write that, anyways. So the third command says that's it. So the third one. So this one I'm going to say Alt F A. So C, I'm going to say env argument. env values in environment values. Let's see. Next is, I want your attention. Actually, I completely forgot that people are at home too. Guys, can you hear me at home or I'm just talking to myself here? Anyone? There are 16 people deep sleep.
Oh,
yeah,
we can hear you.
Oh, yeah, fantastic. Okay, good. So, now this one is important. Pay attention. Very important. Computers have very awkward way to access stuff in the memory. So let's say you have some variable in address 20, okay? And you want to access it anywhere using its name or whatever. The computer finds it like that. The system goes through it like this. So it starts from address 0, keeps going to 20, then it reaches 20, it extracts the value and gives it to you. Now, if you want to go to address 24, it's not going to continue to 24. Again, it goes to the beginning, starts from 0, goes up to 24. So every single thing that you address, it goes from the beginning, kind of, let's assume that way. But it's extremely fast. We good? Are we okay down to this point? Now, to make this faster, how it does is that instead of going one by one, it goes by the size of what you ask to get. So if you want an integer at address 20, it goes 0, 4, 8, 16, 20, and stops and gives you the integer. If you want a character, then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it reaches to 20, and then it gives it to you. Because of this fact, all variables are forced to exist in an address that is divisible by its size. It means an integer cannot exist at address 6 because it's not divisible by 4. It could exist at 0, 4, 8, 16, 20, 24, 28, 32. It cannot exist on any other address than that. If it's a double, it could be 0, 8, 16, and it keeps going like that. We okay? Do we understand this? Fantastic. Now, let's do something. Give me a second. I'm opening my cheat sheet so I don't have to type too much. Okay, that's much better. Okay, so let's say I have a structure that has two doubles in it. Okay? What is the size of rec 1? A double is 8 bytes.
8, 16 bytes.
16. You have two doubles, right? So there's no trick question in here yet. So this is, you have two doubles, it's 2 8s, it's 16. So, and we can verify that. Like, we can literally write something like this. Of course, this is NBB. Okay, so I can write over here return 0. So what sizeof does, sizeof is an operator. It's not a command, it's not a function, it's an operator that extracts the size of stuff. Okay? So if I actually run this program, what I'm going to get will be 16. Are we okay with this? All right. So having said that, let's create another one. So if I have something like this, what is the size of record 2? 9? All right. So 9 is the size of record 2. You forgot the first lecture that I gave you.
Alignment?
It's the fact that I just mentioned to you, a double can only sit at address 8. That is divisible by 8. If character sets, let's say you start from 0, right? The first character is going to sit at address 0. So the next address available is 1. Can double sit on 1? No. 2? No. 3? No. 4? No. And it keeps going until it reaches to 8. 8, yes, puts the double over there. You wasted 7 characters here. And that's the proof. Alignment. Okay? It's not, it is alignment, but I'll get to it. So all, yes?
What if we will change this? First double and then charm.
Amazing. What if we put the double first? And the character next. Fantastic idea. Absolutely no difference. Why? You asked the question, that was brilliant. Why? Because if you want to create an array of rec 2, then it's going to violate the problem, the alignment. If it was 9, then the second element of the array, double should sit at address 10, and it cannot. Because of that, it must design the record in a way that every single variable in it sits at a proper address. Having said that, it is always safest. You can literally create 2 structures. You can literally create 2 structures with the exact same number of attributes in it, but different size if you don't align them properly. That is why to make the size of your record smallest, you must always sort everything in a descending order. Put the biggest one first, then go small, 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 like that. Got it? All right. So what I'm saying is that if I put over here int, what's going to be the size of rec 2? What's going to be size? You can say it out loud. It's okay. Huh? 24? No.
32.
No. Keep going. 92, 60, 156. It remains 16. Because that has the space, right? The first one is at 8, right? The second one is a 4, so it can always sit after an 8. It's perfect. And the other one is 1. But if the next one sits, so I have 8, then I have over here 12, 13, 14, 15, 16. So you only waste 3 characters over there. So now if I do this, you'll see that it's exactly the same. Are we okay? Next question. What address rec1 can sit at? The address should be coefficient of 16 or 8. What do you think? 8. Because a double is 8. You can start a rec at any address that is 8. So size of a record and its alignment could be different. The only way that size of an alignment are always the same, that's for fundamental types. When a type becomes compound like that, it becomes even too difficult to try to think of it. So always use align and size of to see what is the size of the thing that you have and what is the alignment. So don't assume because it's 16, it's going to actually be 16 in alignment. But if you actually want that record to align itself as 16, you don't know why and when yet, it's too rich for your blood. But if you are writing a low-level program and you want rec 3 to align itself as 16, you have to actually mention it to the operator, to the program. You have to say, hey, this thing align as 16. So now, when it creates rec3, it makes sure that it has to align at 16. It's extremely low level. You're not going to have a use for it in 345. But if one day you want to go program a keyboard, or program a mouse, or program a microwave, something that memory management is important, then you will see when you go to low-level assembly programming, you need to align things properly in memory. That's what it's going to come up for. So you can always check to see what is the alignment and what is the size using size of and align of. So now if I run the program, you will see that they're all size 16. The first two alignment is 8, but the third one is 16 because I forced it to be. Be good? All right. Size of and align, or and align. Align of .cpp. Okay. Again, not necessarily C, C++. These work in C2. We talked about void values, and we said void value doesn't exist. It means nothing. Void means nothing. I cannot have a void variable. I cannot say void A. Void means nothing. You cannot say nothing, name is A. Doesn't make sense. Look, it's nothing. You don't need to name, okay? But we can create a void pointer. What is a void pointer? A void pointer is essentially a pointer that doesn't know what is sitting at the target. It's pure address. Because of that, all the pointer arithmetic and target of stuff will go down the window. You cannot, so if you have a void pointer and you have an address in it, you cannot say target of because it doesn't know what is sitting at the target. You cannot say add 3 to the address because it doesn't know what to add to the address. It doesn't know what is the size. Void pointers are essentially created like this. And because it's void, you can set it to any address. So if I have integer I and I have void pointer v, I can set that to address of I. No casting necessary. Because any address is an address. But not all addresses is an integer address. So if you want to use that void back to something, then you have to cast it to bring it back. So void to any, cast it, any to void, not cast it. That makes our life easy. Why? If I want to write a function, low-level function, that I need to, for example, break down any object into its pieces, a void pointer is what is very useful over there. So this is a void pointer syntax. So let's have this as devoid.cpp. So I can actually have, for example, let's say I want to write a program to print the hex dump of any object. Okay, I have a double. I want to see how that double is configured in memory. I have an employee. I want to see how employee is implemented in memory. If I want to write something like that, I need to get their address, right? So the best, I could use a character for the address because that's what I have to break it into. But if I do that, they have to keep casting their addresses to a character. Instead of doing that, I make it a void pointer. I do the cast myself. So they're going to call it easily. Therefore, I can have something like this. So the hex dump of mine will receive a void pointer and an integer that is the size. That would have been a size t. Actually, it's not a good thing to write it that way. So I'm going to write over here size t, since we are writing it that way. And size t, and now in here you simply say, you don't say 4 because you don't know what is the size. you say size of I, and in here you say size of X. So this becomes a system-independent program. Any system, 64-bit, 16-bit, 32-bit, you run it, it's going to work. So what happens over here, it receives the size. This is size PIF, means size of, by the way. It's a new version of size of. Okay. Okay. Size of. Okay. So now I can actually see how these are set in memory. Oops. This is a wrong one. Copy. Copy. Control Z, Z, Z. I changed the wrong file. Yeah, so if I run this 3 years later, it runs and I'll see that 2456 is spread like that in memory and 4.56 is spread like that. So that's a hex value, 3D, 0A, yada, yada, yada. And by the way, this hex, I don't know if you have seen it or not, hex is a manipulator. So essentially, if you say hex, everything's printed in hexadecimal. You can set it back to decimal to go back to normal numbers. Are we good? So that's void pointers. Questions? Suggestions? You're overwhelmed with information? So,
I just the last part of it exactly, but not completely.
So what is the problem?
So we're writing a program to make transfer it to hexadecimal or
So when you write an integer, when you write 2, set integer I is equal to 2. You know you have 4 bytes in memory, right?
Yeah.
And that 4 bytes is set to 2. Do you know what is the bit pattern in there?
No.
Okay, bit. Do you remember the hexadecimal representation? Or should I write it?
Yeah, I know.
You know, so when I run this program, so if I write over here 2, you see that the first byte is actually 2 over there, hexadecimal 2. But if I make that 20, that is 1 4. 1 16 and a 4. 16 is 1 1 1 1. 4 is 0 1 0 0. So essentially, it tells you that the first byte of this thing is 1 1 1 1 1 0 0 0. So we don't know why we need it now, but when you continue learning and hopefully one day you go to assembly programming or hardcore programming, things like that, you're going to see these things come handy. Again, nothing to do with C++. This is C, okay? Oh, this is not C. The C out stuff is not, okay? But size of, void pointer, these are all C. They have nothing to do with C++. It comes from the mother language. We good? We okay? Remember about curve of forgetting that I said in class? Curve of forgetting? Curve of forgetting? The research about how to learn, curve of forgetting.
Yep.
Remember, when you go today, you review 20 minutes. In a week, you review for 10 minutes. In a month, 5 minutes. Then everything's going to fit in. Okay? All right. And I know that you will not do that, but wishful thinking, eh? So hex dump is the one, so EF, so void hex dump. It's like me, I said, tomorrow I'm going to hit the gym. That tomorrow never comes. Okay, so back to C++. We remember that we had references. References essentially were new names that we gave to already existing variables. We good with that? So essentially x ref becomes a new name for x, right? Right? Can I hold the reference? So, and I say 10 is, ref is 10, so essentially x is 10. Are we okay with this? All right. There is another type of reference. That first, for that, we need to understand things that we're going to go more in depth. So I'm going to just give you the surface. What is this? No, what is this? This is an assignment. This is at left, this is at right, correct? We call this an L value. We call this one an R value. So the one that is at left side of the assignment is called L value. The one that is at right side of the assignment is called R value. Are we okay with this? Now, all L values can be an R value. What does it mean? It means I can always do things like this. I can say integer A, and I can say A is set to ref, right? So ref over here is L value, over here is R value, correct? But not all R values can be L value, which means I cannot say 10 is set to ref. Not all R values can be L value. We're clear on this? Are we clear on this? There is a way to recognize if an argument passed to a function is an R value or an L value. You can actually create a type of reference to tell to our operating system, please pick up R values for me. An R value reference, so this one I'm going to say over here, G ref and L value and R value. We're going to go deep in R value and R values and X values and PR values and see exactly what it is later on. But for now, let's just stick to this one. Now, we can actually do... Oh, shoot, I closed it. Damn it. There you go. I can say print int R value reference n. And I can have print constant integer reference n. So this is a regular reference. This is an R value reference. If I call the print as x, an L value will be called. If I call it at 20, an R value will be called. Also, all temporary dying objects are considered R value. Think of int as a regular class, which it is. When you say int x, you're essentially saying create a temporary nameless x, int out of x, a copy out of x that is gonna die after print is done, right? That's what casting is in C. Remember OOP345? When you actually only put the name of the constructor and you pass a value, you create a temporary nameless object, correct? That temporary nameless object is an R value, it's a dying value. Therefore, automatically, print with two references will be called, with R value references will be called. Are we okay with this?
So like in the first part that it says the L value prints the X part, you said that L values can also be R values?
Yeah, but when you put R value, the one that is only R value will be called. Okay? So it will never call X in here. Maybe it will if you don't have any. If I don't implement print, I don't remember, quite frankly. If we don't implement this, it's possible that it's going to call X. Let's try. Good question. Let's try. So I'm going to remove that print completely. No, it won't allow it. And R value reference cannot be bound. So, no. But there is a way to, because there is a way to call it, I thought maybe automatically it will do it. In old time it did. Now we have type safe language, so it won't do it. So yeah, so if I run it, you'll see literally it's going to actually select the proper one as it goes through. So when it runs it, you'll see actually it's going to tell, you see first one is L value, R value, L value. Okay? What is it good for? I'll let you know in a second. E, F, G, H, I. So please keep that in mind. So this is GH is R value. Now, we have a we can actually force a variable that is L value to be passed as R value. So we can force it. How do we force it? This is how we do it. It's called move. Okay? Now you'll see later on why they call it move. But if you put a regular variable, an L value, in a move semantic, it will pass it as R value. So now the first one is going to be X, the second one is going to be R value. Remember that. I'm building up to show you new things to do, okay? So now, as you see, one is L value and the other one is R value. Are we okay with this? So that's forcing. Are we good? So we have an array, okay? With aggregate initialization that we do. If I want to print all the elements in here, what do? I'll go for I equals 0, I less than 5, I plus plus. Then I'm going to say print AI, right? We have a new way of doing it. It's called the range base loop. So what I can do is to see what is the type of the element. What is the type of the element over there? It's an int, correct? So I can say for int element. So this is essentially my element in A. Okay? Then what I can do over here is a C out element and say I put a space over there. Seriously? Oh. So what it does over here is this. It says, this is an element, okay, inside A. Copy each element of A into elem in every loop that you have. So the first round that it goes, elem becomes 1. The second one becomes 2. Third one, 4. It doesn't become. The first one is a copy of A0. The second one is a copy of A1, and it keeps going like that. You follow? So essentially in here, if I say this is what I'm going to get. You see that? So if you change the element, nothing is changed because it's a copy. We good? Are we okay with this? All right. But if you don't want to, and if you actually want to change it, it's easy. What do we do? I can actually make it, also I'm going to say over here, ij range base loop.cpp. So this is what I can do. Take a look. I can actually put it like this. Ta-da! Now it becomes reference of A0, reference of A1. So if you change it, it actually changes it. Now the second one is 0. Oh, it puts it at the other. I have to bring it. There you go. Got it? That is range base loop. Attention. For built-in types, what is a built-in type? Anybody remembers? What is a built-in type? Question for your quiz.
String, SUD string.
No, don't give me example. Tell me what is a
Something that wraps the fundamental ones.
Thank you. Beautiful. Anything that wraps the fund. So for built-in types, which is an array, range-based loops only work in the same scope. If you pass the array to another function using a pointer, then in that function you don't have an array anymore. It's a pointer. Therefore, no range-based loop. Okay? Later on, we'll learn when we learn about STL stuff. In STL objects, where you have classes for arrays and vectors and things like that, then range-based works everywhere. Or for strings, it works perfectly. You can get the elements of a string with this easily. Well, when I say string, I mean string class, not C string. So please be careful when I say string and C string, you know what the difference is. So this is K range-based loop. And array initialization. If you don't mention what is the size, it grabs the size. So the first array is going to be 3. The second one, when you are initializing the array, if it's less than the number, the rest will be defaulted, which is 0. That's why when you put an empty one, it means set everything to 0. Okay? So running this program will result this. The first one is only 3. The second one is 5, but 2 zeros. The rest is all 0. Are we okay? JKL array init.cpp. This was really CPP. It wasn't C++. So now we are going to talk about classes. We said classes are to encapsulate data and behavior. You put the data, you put the behavior, and you set everything. You set the constructor to set stuff. You display them. You know, we know what they are, right? OOP345. Which brings us to shoot, I keep closing it. Initializing a class under microscope. What is initialization? What does it mean, initialization? These are all questions for your quiz. Assignment at the point of creation. Assignment at the point of, so initialization. Initialization. So oh, I don't have it here. I put a wrong one in the other class. Let me bring it up. Give me 2 seconds. Sorry, my apologies. Just a second. Initialization, where is it? We are almost at the end of week 2. So hopefully the next day you are coming in, we're gonna almost go through week 3, and the next week we're gonna catch up, okay? Classes, yes, so this is what I wanted. Okay, and I'm going to put this for the other class too, that by mistake I deleted. Yes. Okay, so class initialization under microscope. First, default initialization in the class. It's something new in C++. When I say new, I'm old. So for you, probably when you were born, this thing come in, but I remember the day that we weren't allowed to initialize stuff, but now you can. Okay, so when you have a very old compiler, it may not work. So, essentially, when you initialize it over here, that's the first thing that happens. So when the class is created, these two objects, the string and the ID, are not created with garbage in them. This will get created with 0 in it, so ID comes to being with 0, and string comes with an empty in it. If you write it over here, it would overwrite the other one, which means now main will be set to this one, not empty. Okay? This is considered initialization 2, and it replaces the other one. Okay? I call this place initialization area, the space between the double quote and the body of the class. That's initialization area, and it's actually proper to write it like this. Because it's initialization, you can actually use curly brackets. It doesn't make any difference. Curly brackets or parentheses work the same way. Are you okay with this? In here, I'm initializing name, ID. This line 12, I didn't realize, will give you warning if you run it on Linux. The sequence of the initialization in the initialization area must match the order over here. Some compilers will give you warning. So this was, I have to actually fix it in the other one too. So this should come over here, and this should go over there. So the order should be like this. You should keep the same order. So it could be like this, and here, and here. And then, so this is step 1. Step 2, this is when initialization is over, which means when you come here, too late to initialize anything. All attributes are created now. So all you do, if you write something in the code of your constructor, all you are doing is setting, which means they got created however they were supposed to, and now you're overriding them. If you didn't set them, they're going to have garbage in it. If they were initialized, they initialize with default initializer in here. Okay? Are we good? That's that. Classes. So M, N, and I'm going to copy it, Control A, C, put it for the previous class, Control V, save. Okay. And now the last thing for today that we are going to cover. Please, when you go home, read everything in too, and so when I'm coming in, I can go through it faster, okay? And if you have any questions, ask me. All right. Now, let me see if I can actually bring up the... I need an actor with a bottle or... Okay, the gentleman over here has bottle. You're my friend today. Hello. How are you doing? Everything's good? You do? Oh, you have a bottle too? Good. So, yeah, come. He's deep in thought. Like, woohoo! Okay. I thought you were talking to me. No, because the gentleman over there had a bottle too, but he's in some other work right now. He's not with us. Okay, so now I'm gonna still gone. So let's see if I can actually bring this up. Ah, no, not this one. I don't want this one. Is this the one? Okay, how do I close this? Anybody? Oh, there you go. Let me open up the other one. So I'm going to go to here, camera. Yes, that's the camera. And that's you standing over there. So I'm going to go on Spotlight over here. Spotlight for everyone. Yes, so let me come. All right. All right, so I am a function called coffee that returns coffee. He's a caller of function coffee who wants to get coffee. You don't need to open it. We're just going to pretend. Okay? I'm not going to give you my coffee. So it's iced coffee. All right, so what we do, when I return coffee, I make brew coffee do whatever I want to do. Then I want to bring it up. Now I want to give my coffee back, but there is some barrier over here that doesn't let me to go through. What is that barrier? It's the scope of my function. The scope of my function doesn't allow any local variable to go out so I can give anything to him. That's the paradox for returning something from a function. When you return something from a function, how can you return something that is dying? It's going to be dead. So how does the compiler fix the problem? Compiler brings a third cup, creates a copy of this cup, okay? And copies all the content. So essentially rebrews coffee. It doesn't get the content of this. It literally makes a copy exactly how I brewed the coffee. Brews the coffee, brings it over here. Now, he copies this over here, then this copy goes to garbage, mine goes to garbage, now he has coffee that is identical to mine. It is not mine, it is identical to mine, it's a copy of mine. You understand? That's awful. Imagine that I have a function that is, okay, let's do it like this so we don't get tired. Oh, stay here. So let's assume that I have a function that receives 5 billion numbers, samples of something, like SATI. We are actually searching for extraterrestrial thing, and we are receiving information from the universe, and we are saving it on our computers. and I'll get that information and I want to pass it to someone else. It's 5 billion integers. If I want to return it to that, it has to copy 5 billion things, give it to that guy. That guy is going to copy it, another dynamic schmiggly-dingy. Then that temporary thing is going to die. Mine's going to die. It takes forever. Why don't we just do this? If I want to give you coffee, I'll bring the coffee. You just bring the cup close to mine. I'll empty the content of mine to yours, and I'm done. He has coffee. It's actually what I brewed. It's not a copy. I moved the coffee off mine into his. My cup didn't go out. The content was passed through. Now I have an empty cup that I throw away. He has a full cup. Why don't we do that? That is called moving. Thank you. That is called moving. That's what we do. So now, rule of 3, which was copy constructor, copy assignment, and destructor, is added by 2 more things, move constructor and move assignment, which means using those R value references, we can detect if something is temporary or about to die. Because we can detect it, instead of copying everything that it has, I simply am going to point to that data and make the pointer of that guy null. Therefore, what happens, it's going to lose its data, I'm going to get its data, and life is beautiful. It's called move construction and move assignment, which we're going to learn in a second and a half. Are we okay with this? All right. Exit spotlight, camera off, and let's continue. Oh, the recording, I should have brought it into recording because the YouTube one, they're not going to see it. They're just going to hear stuff. Anyways. Let's write code. So, I'm going to end it with this today, so be happy. I see sadness in some people's faces, but be happy. Life is good. So let me just bring something, an OOP345 thing up. I'm going to quickly go through it. Okay, so that's that. Then we have copy assignment. Then we have display and some few things that we have in here. All right. So let's take a look at what we have. First of all, at the end of the class, can you see this? Or it's too small? Can we see it? Madam, are we good? We're good? Okay. I have a class called name. First and last is dynamic, OOP345, right? I create a set function. Remember allo copy that I created last semester? It's the same thing over here. So it's essentially allocates and copies. So this set thingy, you put it first in that, it deletes what I have currently, removes if I have anything, then if first exists, copies, the second exists, copies, and yada yada, okay? We're good? So essentially allocates memory, dynamically sets these two. Are we okay with this? I'm gonna reuse this. So set dynamically allocates stuff. Constructor, first, last, set first and last, right? Dynamically sets it. Destructor, so one rule is done, destructor is done. We're good? Deleting? Any question on that? Copy constructor gets the other and sets the current one to the first name and last name of the other. We good? Are we okay? And then we have assignment. What does the assignment do? First, self-checking. Make sure I'm not copying myself. Make sure I'm not copying myself. And then what it does, it sets it to the other one too. Are we okay? Then I have a display that displays everything. Then I have an overload for cout, so I can just show the object. All straightforward stuff. Now I have a function called makeName. So what this function goes, it creates a temporary thing called name, then it returns it by value. Imagine this is getName and it's receiving something from console. So somebody's entered in console, you create a function called getName. And I have a print by value over here, printing something by value. Now if in main I create this name and I pass, copy constructor will be called by n1y because it's passed by value, the copy constructor will be called, right? And now in here I'm saying makeName. This makeName is exactly a coffee scenario. It has a temporary name that is created, wants to pass it by. So again, copy constructor will be called to create a copy of the temp, passes the copy over here so N2 can get copied out of that one, then the copy dies and a temp dies, right? Not on my watch. I'm not going to do that. I'm going to actually create an assignment, because this is an assignment, right? I'm going to create what we call a move assignment. So I'm going to come over here. I'm going to write name, reference, operator, same thing. This one is not going to be constant because I want to steal the other thing's name, content. So I'm not going to make it constant. It's going to be name, and I'm going to say when it's temporary, other. Now, please, don't ask me why. When we teach exceptions, we're going to tell you, what is this? No exception is what you're going to write over here. Why? Because the sky is high. It's a syntax. Do it, okay? Later on, I'll tell you what it is. If you don't write it with work, but it's going to give you a warning. So put that thing over there. I'll explain to you later on what it is. But think about it. It's just an assignment operator when the other one is temporary, right? Here, exactly. So that's exactly what I have at line 81 over here, right? So I'm saying name. Actually, this is a constructor. So this is actually a constructor being called. So I can do the exact same thing with a constructor. It doesn't matter. So I'll come to the constructor. Because it's at the moment of creation, it's actually a constructor, not assignment operator. So I can write over here name, name, other, no exception. Right? Correct? So now I am building this object out of the other one, right? So the other one has some data, correct? I'm going to say my first is equal to, will point to the others first. My last with point to the others last, right? So now we are two objects pointing to the same place in memory. That's disaster, right? Easy. I'm going to say, now that I am pointing at yours, will point to nothing. Done. No allocation, no memory, nothing. I literally stole the other guy's data. I'm saying I am pointing to your first name and last name, and you don't point to anything. It's done. So when this line happens down here, what happens is that the temporary that is receiving literally the Alice in Wonderland that it has, that is going to point to Alice in Wonderland that is dynamically allocated, and temp loses its connection. Then temp becomes an empty object that dies. And I have the dynamic memory that the other one allocated. And life is beautiful. And it's the exact same thing with the assignment. The only difference is that over here I have to say if this is not equal to the address of the other to make sure that self-copying doesn't happen. and then return this at the end. But the logic is identical to the other one. Ta-da! Rule of 5 representing. Very good? We're done for today. Questions? I want you to go home and digest this, please. Run it. And I didn't even run it. It may have bugs. So go home, fix it, and write some scenarios and see how it works. We good? Okay? So the next day you are coming in, we're going to start with this. So we're going to go through this again. Okay? But these are essentially rule of 5. Any questions? Five minutes to go, right? 11:40 it ends. I have time to actually upload the video right now, so I'm good. Okay, have a beautiful day, everyone. People at home, you didn't say anything, so I assume you don't have any questions. Do you have any questions? Anyone? No?
No, sir.
All right, have yourself a beautiful day. Bye-bye. And meeting, and